Okay, these are 6-8 notes. In this chapter, we've been talking about systems of equations, which is two or more equations that have a certain solution. And those solutions could have been one solution, infinitely many solutions, or no solutions. And in chapter 5, we talked about something called an inequality, which is where we had greater than, less than, greater than or equal to, less than or equal to. So we're going to combine those things, and instead of talking about a system of equations, we're going to talk about systems of inequalities. Now, a system of inequalities is two or more inequalities with the same variables. Before we get too far into this, I should remind you that you're going to need a ruler and maybe a couple different colored pencils, or I'm going to use highlighters today, something along the lines, but you're going to need two different colors. So when we talked about systems of equations, they only had one solution or infinitely many solutions or no solutions. But we could have sets of solutions, and I'm going to show you on the graph down here what that's going to look like. But when you start solving systems of inequalities, it's easiest to graph them so that you can see that you're going to get a whole set of ordered pairs that make both inequalities true, because remember, when you shade on one side and then you will shade for the next inequality, you're going to get some things that overlap, and you'll be able to see the set of ordered pairs that make both inequalities true. That might seem really confusing right now, but once we get this first graph done, you'll see what I'm talking about. Same thing as in chapter 5, when you're graphing an inequality on a number line, you have to worry about the dotted lines and the solid lines. First thing you want to worry about is it in slope-intercept form? And if it isn't, you need to change it to that way first, then graph both of them, and then we'll do the shading. So we're going to do a couple examples together to refresh your memory and show you what the new stuff looks like, and then I'm going to let you do a few on your own. So first things first, I need to graph both of these. I'm going to graph the first one in blue. So I have y is greater than negative 2x plus 1. This is in slope-intercept form. Positive 1 is my intercept. Negative 2 is my slope, so I fall to run 1. Then use your ruler. This is just a greater than, there's no equal to sign, so I'm going to use a dotted line. Okay, and then I'm going to use pink. Oh, actually, let's go ahead and we'll do our shading first. So I'm going to pick the ordered pair 0, 0 for my test point. Plug those in, so I get 0. Is it greater than negative 2 times 0 plus 1? Is 0 greater than 0 plus 1? No. So I shade on the opposite side of that ordered pair. That ordered pair is here. And I'm going to, I should have just used this. Okay. Then I'm going to do the second equation in pink, and I have y is less than or equal to x plus 3. Already in slope-intercept form. My intercept is at 1. My slope is 1, so I rise 1, run 1. It's greater or less than or equal to, so it's a solid line. Okay. I'm going to use the origin again as my test point. Is 0 less than or equal to 0 plus 1? 0 is less than or equal to 1. That's true, so we shade on this side of the inequality. Okay, so we can see that this little triangle, and of course it keeps going out because our arrows never stop, but this little triangle overlaps. I have purple and green there, so I can see that this set of the ordered pairs makes this system of equations true, and that is my solution set. I don't have to write anything else in there, I just have to have that graph, okay? Let's turn to the next page. And here's another example. This one, however, gives us one that's not already in slope-intercept form. So this will be a good refresher for you. So first thing I have is y is less than or equal to 3. I don't have an x, so I know I have to make a t-chart for this. This one gives me y, so that's where I'm going to put 3's. And I'm going to go with -1, 0, and 1 for my ordered pairs. So -1, 3, 0, 3, 1, 3 are my ordered pairs. Now, I know I'm going to have a horizontal line, but I also know it's going to be solid because it's less than or equal to. Okay, pick a test point. I'm going to go with the origin. When I plug that into y less than or equal to 3, I don't have an x, so I don't worry about it, but is 0 less than or equal to 3? Yes. So I shade on that side of the inequality. Okay, let's go ahead and do the next equation. I have x plus y is greater than or equal to 1. I want to make it look like y equals mx plus b, or sorry, yeah, we're going to have some inequality, but we're going to put equals. So I know I have to get the x to the other side, subtract x. Don't forget the rules. We don't have it in this example, but don't forget the rules that if you have to divide by a negative number, you have to flip the inequality sign. So I have y is greater than or equal to -x plus 1. My intercept is at 1. My slope is -1, so I fall 1, run 1. And it is greater than or equal to, so I have a solid line again. Okay, choose a test point. I'm going to go with 0, 0. 0 is greater than or equal to -0 plus 1. That's what we're wondering. Is 0 greater than or equal to 1? No. So instead of shading on this side, I shade on the opposite side. So that's what my shading will look like. And I can see that this triangle is where my two colors overlap. It might be hard for you to see in the video, but this one's actually a little bit darker because of the purple. So there again, that's my set of solutions. So you have two more. Actually, I just want you to do the next one on your own. Go ahead and try this next example on your own. Pause the video, do all of your shading, and then come back and check. I'm going to keep going. So I have x plus y is greater than 2, trying to make it slope-intercept form, so I subtract the x. And I have y is greater than -x plus 2. So my intercept is at 2. I have a slope of -1. It is just greater than, so it is a dotted line. Choose a test point. I'm going to choose the origin. Is 0 greater than -1 times 0 plus 2? Is 0 greater than 2? No. So I shade on the opposite side. Okay. Then I have -4x plus 2y is less than 8. I want to get it to slope-intercept form, so I'm going to add the 4x. I get 2y is less than 4x plus 8. Divide both sides by 2, and because I'm dividing, I have to do it to each term. Y is less than 2x plus 4. My intercept is at 4. I have a slope of 2, which means rise 2, run 1. And I have just less than, so it's a dotted line again. Choose a test point. I'm going to go with the origin. Is 0 less than 2 times 0 plus 4? Is 0 less than 4? Yes. So that's the side that I shade on. So that section where those overlap is the set of solutions. Alright, go ahead and turn to the next page. This is just another example, but we're going to find out that sometimes we have no solution. And this is an example of that. Let's go ahead and just start graphing each of the lines. I have 3x minus y is greater than or equal to 2. Want to get it in slope-intercept form, so I subtract the 3x. I get negative y is greater than or equal to negative 3x plus 2. Divide each term by negative 1. I get y. Now, I divided by a negative, so I flip my sign. Is less than or equal to 3x minus 2. My intercept is at negative 2. Slope of 3, rise 3, run 1. Okay, it's a solid line. I'm going to choose 0, 0 as my test point. So is 0 less than or equal to 0 minus 2? 0, is it less than or equal to negative 2? No. So I'm going to shade on the other side. Okay, let's go ahead and deal with the next one. I have 3x minus y is less than negative 5. I'm going to subtract the 3x. I have negative y is less than negative 3x minus 5. Divide by negative 1 on each term. Y is greater than, I flipped my sign, 3x plus 5. My intercept is at 5. I have a slope of 3. Now, I can't rise 3 and run 1 on this graph, so I'm actually going to fall 3 and go to the left one, which gives me the same idea. It is a dotted line. Okay, I'm going to choose a test point. I'm going to go with the origin again. And I get 0 greater than or equal to 0 plus 5. Is 0 plus or greater than 5? No, so I shade over here. So, as you can see, all of the shading for this one keeps going this way, and this one goes this way. They'll never cross. So, there is no solution here. They don't ever overlap. So then we write down here, no solution. Okay, that is actually the end of the notes. So if you have any questions, let me know. Be sure to come see me before school if you need help. We will work on this tomorrow, class, and I will see you then.